In this video, I'm going to evaluate this limit. So the first thing I'm going to do is check my type. So when I evaluate this at x equals 0, I get 0. And I know that this limit, as x tends to 0 from the right, does not exist. So my type is 0 times dne, which is an indeterminate form, which means I can't say what the limit is. I have to do something else. So I can see that this is a good candidate for the squeeze theorem. The reason is that cos of pi over x always sits in between -1 and 1. So I'm going to go ahead and start with that. So I have cos of pi over x between -1 and 1. And what I want to do, I want to get this function in the middle of this inequality. Now note that this is a square root, so it's always positive. So I can multiply it through this inequality, and that won't change the inequality. So let's go ahead and do that. So I get minus the square root of x cubed plus x is less than or equal to the square root of x cubed plus x times cosine of pi over x is less than or equal to the square root of x cubed plus x. Now looking at this, I can see that as x tends to 0 from the right, this is going to tend to 0, and this is going to tend to 0. So I can see that by the squeeze theorem, this function in the middle, which was the function I'm looking at, that will also tend to 0. Now let's write that up properly. So we can say that since the limit as x tends to 0 from the right of minus the square root of x cubed plus x is 0, and the limit as x tends to 0 from the right of the square root of x cubed plus x is 0. So that is these outer portions. We can then say by the squeeze theorem, the limit as x tends to 0 from the right of that middle function, x cubed plus x times cos of pi over x, is also 0.